Better Buildings for Humans is powered by Advanced Glazings, makers of the Solera line of products. Solera is the leading glass glazing made specifically for architectural daylighting and with extreme insulation performance. Learn more at advancedglazings.com. Hello and welcome to this week's episode of Better Buildings for Humans. I'm your host, Joe Menchefski. This is the podcast where we take a look at the impact that the built environment has on our health, our wellness, our productivity, and our general joy of being alive. And I also talk about sustainability a whole lot as well. And on that note, our guest today, his name is Bryan Eagle. He is a serial entrepreneur who's had some tremendous success. Looking at his resume is a pretty impressive trip. And Bryan is working in the space of sustainable design now, sustainability. And his new company, Glanris, covers a lot of bases and a lot of markets in the world of sustainability. And that's why I really wanted to have him on the show today. Bryan, welcome. It's a pleasure to get to speak to you.
Yeah, thanks for having me.
Yeah, no, it's wonderful. It's an honor. So you've had an interesting career and you're doing some really interesting things right now that's relevant to me and to this audience. Can you tell us about your background and the path that led us to the creation of Glanris? And you don't have to rush because you've done some really interesting stuff.
It is a long and winding road, that's for sure. No straight path from point A to point B. My background is all in the wireless data communications arena. So both terrestrial and satellite wireless data communications. I've been designing and building and implementing applications, hardware, and networks, since the late 80s. Initially in satellite, and then as cellular started to take over, shifted a lot of this to cellular. What really, I think, got me firmly down the what we now call IoT path was designing for Coca-Cola a system to monitor all of their vending machines, which is a platform that they're still using today. Hugely impactful in driving not only sales, but also route efficiencies for them, and really demonstrated the power of remote monitoring of these sort of fixed assets out there and what kind of efficiencies could be driven from that. And so sort of from there, moved into doing a lot of work with other cellular router providers and data network services companies. And then the last thing I did before Glanris was helping a Swiss CubeSat satellite network get launched, quite literally, where we were building a network of CubeSat satellites, literally the size of a shoebox, to monitor everything that isn't covered by cellular. And when you really take a look at the globe, about 90% of the Earth isn't well covered by cellular. Now, most of that's sea, but also a lot of remote areas. And this network was really for monitoring those assets in that area, pipelines and buoys and things like that. And then I'd been approached to take a look at this technology and to think about investing in it, Glanris. And the idea, early concept that I saw was to take rice hulls, which is probably the world's largest ag waste product, is what comes from rice because it's so prevalent around the world. But, the rice hulls and the rice stems constitute 90% of the plant. So what you're harvesting is in the rice is a small percentage of, the rest of the harvest. So you got to do something with that waste. And across the river here, I'm in Memphis, Tennessee, and across the river in Arkansas is where most of the rice in the United States is grown. So they generate over 2 million tons of rice hulls that there's really no market for. And the original concept for Glanris, and Glanris is sort of a mashup of Gaelic words, Glanris, which means clean rice, and its original focus was to turn that into a water filtration product. because if you pyrolyze it, which is to cook it at high temperatures in the absence of oxygen, you take all this plant material, carbohydrates, and you cook off all the OH groups, and you're left with just carbon. And think of it like activated carbon. A lot of people have heard of that. That's in water filtration techniques. If you've got a water pitcher filter, chances are, there's activated carbon in that. And what activated carbon does is it removes organic impurities. What we found a way to do with these rice hulls is to also give it the capability to remove heavy metals. So now in a single media, you've got an organic filtration media and something that will take out heavy metals. And that's kind of how we got started. Very cool technology. And unfortunately, what we found in the water filtration world is that it ain't broke and they ain't fixing it. And it was a heavily regulated, slow to innovate marketplace. And while we're still pushing that in that space, and we found a few niche markets in that, we really started to branch out about 2 years ago to look at other markets, which brings us to where we are. So when you take plant material and you turn it into carbon, what can you do with carbon? Well, carbon's one of the handful of building blocks of pretty much everything on the planet. So there actually is a lot you can do with that once you turn it into this carbon. But one of the interesting things about rice hulls is that they're very high in silica. And that silica actually has, as for your audience, has very high pozzolanic reactivity, which means it's a pozzolan. It has cementitious properties. So we started working with a handful of universities in the United States where they were doing research and provided them with our materials, where they were looking at how to, basically decarbonize concrete. And, there are several approaches to that. One way to decarbonize concrete is to, because the process is basically create CO2. I mean, that's what you end up with when you get these calcium carbonates and then you cook off the CO2, you're left with the cement, basically.
Plus the energy to actually drive off the carbonates as well.
Yeah,
so
and a lot of energy, right? So it's a very heavy carbon footprint business. So a couple approaches. One is, you can fire that kiln with greener energy products. That's one way. Another way is that you can capture the CO2 that's coming out the stack and do something with that, trying to pump that underground or something like that. Or you can replace cement. Because when you take a look at concrete, about 10% of concrete is cement, but it accounts for 80% of the carbon footprint of concrete. And ordinary Portland cement, which is the process we were just talking about, is, only been around since the late 1700s, early 1800s. I can't remember the exact date. And we've been building buildings on this planet way before that with mortars that are still standing. I mean, you take a look at a lot of these Roman ruins that are around, they're still holding up pretty well, 2,000 years later, without the use of ordinary Portland cement. So that's where we came in. We are a pozzolan, or cementitious material, and we can replace part of the ordinary Portland cement, in some cases be able to replace all of the ordinary Portland cement, depending upon what you're doing with it, what you want to do with it. In addition, what we create, where we're taking plant material and cooking it, in this industry is called biochar, because it's a biomass that's been charred, so biochar. And there's also the opportunity not just to replace the cement, but also to replace some of the other components. So remember, concrete is like 10% cement or 11% cement, depending on what you're doing. And then you've got fine aggregates and, aggregates, larger aggregates, gravel and sand in a lot of places, stone and sand. Then water, those are your other components. So there's the opportunity to take other biochar material, woody-based biochar, other ag waste-based biochar like nutshells, etc., harder material, and use that to replace some of the fine aggregates. So by combining all of that together, you can end up with a carbon neutral concrete. And we've done a lot of testing with this with these universities, looking at the compression strength, the tensile strength, how it freezes, how it thaws, what sort of issues that they find. And again, there are always going to be changes when you start switching up material and how you mix and all of this. But largely what we found is, and people use different plasticizers, depending upon what they're trying to do. Because depending upon what you're trying to build, you can certainly create a concrete with the same or better compression and tensile strength. Also, it reduces microcracking in the material. So you can use it for applications that it might not be used for. So I guess I'm doing all the talking. I'll stop.
No, I love that you're doing all the talking.
Yeah.
I love that you're doing all the talking. Okay, but there's a lot there to talk about. I mean, first and foremost, carbon neutral concrete, like the world should be beating a path to your doorway. I've had, I can't remember his name, from the Concrete Association recently. You go to every sort of conference that discusses sustainable design in buildings. The concrete is in the crosshairs at every single conversation, and you've explained the reasons why already. How much uptake are you getting on this technology, Bryan?
Well, remember when I said that water was a heavily regulated, slow to innovate industry?
Yeah.
Well, guess what the concrete industry is?
Yeah, of course. Yeah.
Heavily regulated, slow to innovate industry.
Yeah.
And we've got a little bit of a scale problem because, when you go and you talk to cement companies, right, as Cemex or Heidelberg or one of these big guys, and you say, hey, we're doing this stuff. And they go, well, we've already got supplemental cementatious material. We got fly ash, coal fly ash. Well, hey, ours has higher pozzolanic reactivity than coal fly ash. So, that's cool. And oh, by the way, we're not burning as much coal as we used to. So, that's going down. You need to find another replacement.
Why is it cool? You mentioned the higher pozzolanic. Is that the right word? Am I using it?
Yeah, pozzolanic.
It's a new word for me. So why is it advantageous to have higher reactivity?
It's just a bonding property.
Okay.
Basically.
So you just get a better bonding, better aggregation.
Yeah.
Okay.
Again, there's lots of subtleties in how you mix and everything, but yeah.
Okay.
So they're like, great. That's very interesting. Now, we buy 1 million tons a year of this material. How much are you producing? Okay, well, we're producing, the industry overall is producing in biochar right now, which is a new process and a new industry. The whole industry is producing a couple 100,000 tons a year. So the cement guys go, man, my smallest plant generates 3 million tons a year. So if you want to really make a dent here, and we're going to start looking at this, you guys got to get the scale up. And of course, the industry responds with, great, give us the order and we'll go build it. And
right.
They go, no, you get it up there and then we'll take a look at it and then maybe we'll buy something. So, for the big guys, right, the large ready mix guys, the cement guys, they're following it, certainly very interested, as everyone is. The folks in California are a lot more interested because now have regulation in California that they must have a carbon neutral, if not negative, concrete by 2045. Now, that's a ways off, but
it's not that far off.
Exactly. It sounds like, well, that's whatever. But you're right. To change an industry as big as this, to move that aircraft carrier 2 degrees to the right, it takes time. So,
yeah.
California's very interested in this, and we're actually working with the university out there who is doing a lot of work with Caltrans on doing now pad trials. So, we've done the mortar cube trials, now we're into the cylinder trials, and now moving into the large pad trials. And then ultimately that will move into testing. So we'll actually do some walkways, non-structurals, until it gets ASTM certified. But, good news is there now is an ASTM subcommittee, which we're part of, that is looking at biochar overall applications and to get those certified, ASTM certified. Because if you want engineers in this industry, architects and engineers who are speccing a lot of things or approving things in this process, they're going to feel comfortable legally to do this if there are these certifications that exist from standards bodies like ASTM. So again, it'll take time. I mean, it's not something that, will happen overnight, but at least now we're on the path down that way. So what do you do in the interim? Well, in the interim, some of the interesting things you can do is work on non-structural things like pavers. So here's an example of an architectural tile. It's also if it was thicker, be a paver. And if you sort of replicated this, it would look like fish scales. And you can create, you can make this into anything. Make it look like fish scales or circles or octagons or whatever form you want. But that's a smaller market and one where you don't have to show up and say, yeah, I can make 1 million tons of this stuff for you. It's a much smaller entry into the market. And we've got a couple of people that we're working with on these sorts of products, one of which I'm very excited about because it looks like fieldstone and it's fireproof, or I should say fire resistant. You can't really make the fireproof claims, but it's fire resistant. So for California and our facility out in Sacramento Valley, to be able to work with these guys, partner with them to produce something that can be used in the rebuilding of LA and Paradise and all of these places with material, which is not only more sustainable, but also fire resistant, we think is pretty powerful.
Manage the connection between building occupants and the outside world using Solera translucent glass. Learn more at advancedglazings.com. So let's talk about business model a little bit. So you've got the technology for doing the conversion to the biochar. Will that be done in a central location? Are you going to need to have kilns in multiple locations? Or is the business model that you'll be selling or leasing kilns to people? How do you see that business model playing out, Bryan?
Yeah, it's a great question. And there are actually a couple of answers to it. But in our world, we actually produce 3 things. We produce the biochar, and different biomass makes different types of biochar. If we produced a biochar from nutshells, it would not have any pozzolanic reactivity. It's the silica in the rice stems and hulls that does it. So we produce biochar, and we can make different biochars that have different applications. Because there's a lot of heat involved, we have the opportunity to use that heat to produce electricity. So we can produce electricity when the sun isn't shining and the wind isn't blowing. And that's pretty interesting in places like California where, they've got some real issues with the grid right now and it's very expensive. Well, for us, that's a byproduct of what we're doing. So we can actually produce it very inexpensively. And then lastly, this whole process of taking this plant material, which otherwise would have rotted or been burned, and turn that into this stable carbon, which sequesters carbon. It pulls it out of the carbon cycle and prevents it from, creating greenhouse gases. That is carbon negative. So we actually create carbon credits. So we have the opportunity to sell 3 things: the carbon credits, the electricity, and the biochar. And what makes it potentially a regional business is that, particularly in California, they want, distributed electricity generation. So one big plant somewhere that's doing all this stuff, puts a lot of strain on the grid. But if you have lots of little plants around, less strain on the grid, and also it's more sustainable and gives you more carbon credits. Because if you don't have to truck the biomass in from 1,000 miles away or 100 miles or 200 miles away. But if it's coming from 10 miles away, 20 miles away, it's a lower carbon footprint to get that material there. And if you're selling it to, Paradise and you're near Paradise, California, then you've got a lower footprint to get there. So your carbon credits go up because it's all a measure of not only the carbon footprint to bring material in, the carbon footprint to make the stuff, and then the carbon footprint to get it there. So as I said, we sell three things. So what we're seeing is that it's sort of beneficial for us to have, smaller, more regional facilities, but you also want to get to scale. So you're really looking to pick those regional locations so you've got enough biomass within 100-mile radius and enough customers within 100-mile radius that it makes sense. So complicated answer, but that's really the calculus of what that we're doing to figure out some of the best places to put this.
Well, outside of California, what does the calculus show? Do you have any other locations that you would say that's an optimal place, that's an optimal place, that's an optimal place? Do you have a partial list assembled yet?
Sure. There's rice grown in California. They about 10%, 10% of the US production. So there's sufficient quantities out there to produce material like this.
Okay.
And here in Arkansas, there's a lot more. We produce 55% of the rice in the United States is grown just in the state of Arkansas. It's not a huge state. Mm-hmm. So, heavy concentration. So around here would be great for things like rice hulls. The problem is in California, electricity costs 21 to 41 cents per kilowatt hour, depending upon peak usage and what else is going on. Unfortunately, in this area, you've got a lot of hydroelectric dams, and so it's very cheap. So, the business customers are paying anywhere from 4 to 5 cents a kilowatt hour.
Wow.
So it's less attractive. And frankly, there's just not a lot of interest in green products, and particularly green concrete or cement. So we'd sort of moved away from this area. But again, I think anywhere you're going to find the concentration of biomass and the concentration of potential interest in these products. And frankly, I think that's probably going to be coastal. In California, you're going to get a lot of agricultural waste products. On the East Coast, you're going to get a lot of woody waste products. So I think that's where we're going to see expansion.
So you'll see different feedstock in different geographical areas to serve different markets. Is that an accurate statement?
Yeah. Again, as I said, the rice hulls have this high pozzolanic reactivity, so they can be a cement replacement. But woody-based biochar, and on the East Coast, is a lot of, so sort of tree cleanup and tree waste and the stuff that municipalities take care of, or every time there's a storm, you got to clean all this stuff up. I mean, there's a lot of this wood waste. Well, that's great in replacing the aggregates in concrete. So, again, different products for different parts of the application.
Yeah, it's fascinating. You have to be aware of both inputs and market, supply side and demand side are driving you, and you're looking for that right intersection. Does that take you, like when we go outside of America, you've got significant raw materials in, say, the Far East, but at the same time, you've got the European market is a lot hungrier for more sustainable products. Have you looked in these sorts of geographies? And if so, is there a big flashing sign that says, here, these are the places that we need to put some effort?
Absolutely. I was just on the phone yesterday with a group in Europe. There's a lot of rice hulls, a lot of rice produced down in Spain and in Italy.
Right.
And, they've been looking at these applications for quite some time. So they already have some lower value applications, but they're very interested in what we're doing in some of these higher value applications. So, a European location is something we're certainly very interested in. In addition, we've been contacted pretty much in every rice growing region of the world. Kenya, Laos, Malaysia, Thailand, Vietnam, Japan, the Philippines. I know I'm missing a few in there, Egypt, about potential partnerships. And we're exploring those. All of this is new, right? So it's hard for some of these guys in India. I knew I forgot one.
India. Yeah, of course.
Major rice group. But it's hard for them to kind of get over that initial hump of, well, where are the markets for this? I think, as I've said before, these tiles, these pavers and tiles, I think is the way to go in these markets. And that's what we're trying to find. And we've talked to a couple of cement companies, one in Thailand, that have some interest in this and are, in fact, looking at the paver market. But as with any, a lot of these are pretty big companies, or in some cases, state run companies, and they're just another slow to move entity. But certainly what I found as an overall overarching interest is that there's more willingness and interest in sustainability products overseas,
right,
than there has been overall in the US. And largely that's because, in Europe, it's being regulated, right? You've got to get to this. So in places like California, where it's being regulated, yeah, there's a bit of a fire there. But in other parts of the US where there's no regulatory pressure or consumer pressure on them, people are, if it ain't broke, they ain't fixing it. So I think when you start looking at, at some of these other markets, you see them, the state is on a national basis pushing some of these sustainability programs and circular economy initiatives. And that's what's driving a lot of the interest there.
It's a really interesting challenge, isn't it? Absolutely love it. It would be a great sort of MBA thesis project or PhD in business thesis project or economics to really understand all of the, how the different factors push and pull in the different geographies. But yeah, it's a fascinating challenge. I want to move away from it for just a minute, Bryan, because there was something in your resume that really caught my eye, and I just wanted to take a moment to discuss it. You are on a board of an organization called Resilience Education. Can you tell me a little bit about what that organization does and what its goals are and how it's going about achieving those goals?
Sure. So Resilience Education is a nonprofit entity that was founded out of the University of Virginia's School of Business, the Darden School of Business. Well-known business school in the United States, top 10. And one of their professors received a letter from an inmate at a local prison saying, how do I learn about some of these issues of finance and business? And I can't, I'm a little constrained right now. I can't come to class because I'm locked up.
Right.
But what does Darden have and what are the sort of the outreach possibilities? And that got him thinking, this is interesting. Maybe we can take some of the case studies that we do and boil them down to something that in some cases people who may or may not have a GED could take and give them some financial literacy, because this was also identified as one of the major problems in the prison population. And that was about 13 years ago. And since then, that program has grown and morphed a bit. Now, the business school students at Darden actually teach these classes using the Socratic method in prisons. And the Socratic method, which is asking questions and sort of eliciting answers, is very powerful in the prison population because a lot of these people, their lives have been diminished. And so now they're being asked their opinion and they're being asked to think, and it's empowering for them. It's also empowering for the students because once you teach the material, you're going to have much higher retention of the material. So it's now become, one of the higher rated classes at Darden in terms of how impactful the students rate it. And we've graduated over 1,100 students who have come through the program and then gotten out of prison. And the impact has been incredible. So in the United States, and we do a terrible job here because we like to throw people in prisons for stupid things, and the recidivism is very high. So, on average, across the country, you think about a 50% recidivism. And that means that 50% of the people that get out of prison end up going back to prison. Well, why is that? Well, it's because they didn't have the schools and the self-confidence to be able to survive in the world afterwards. And so, what we've seen over the course of, 13 years, 11 years of really doing it on a solid basis, is that we've been able to take that recidivism, depending upon how many classes you take from us, down to 0% in some cases, 3% at the max. So that's a huge swing in the national recidivism rates. And it really is about giving people the self-confidence and the tool sets to be able to survive in the world. And then after they get out, we have a post-release program called RPC, the Resilience Professional Community, which links those formerly incarcerated and justice impacted folks with these business school students. And now it's expanded from Darden to Columbia to Wharton, Georgetown, and we're talking to a number of other business schools around the country. And so you get plugged into this network of business school students from the top business schools in the country who are now in large corporations and can be helpful in giving opportunity and mentorship to these justice impacted people. Because a lot of times when they're working in these large companies, they, in the employment application, there's the box that you got to check there that says, have you ever been convicted? And, huge stigma. And so what they're now doing is saying, well, look, maybe we should get rid of the box because that may be important in some industries and for some applications. I mean, if you were convicted of securities fraud, you might not be able to get a job back in the securities industry. Yeah. But if you were convicted of possession of marijuana, why should that stop you from getting a job anywhere, frankly? So that MBA population is now not afraid of justice impacted people. They've worked with them. They know what that looks like. They know what kind of skills they can bring to the table. And they're able to provide opportunities. And we've seen several notable examples of this where, these folks have come out and gone on now to have decent positions in some very large companies. I mean, VPs of publicly traded companies. So I'm very excited about the work that they're doing. And we're very excited about the potential for education in prisons, to help provide opportunities to reduce recidivism. Because there's a real cost to that. To house somebody in prison is expensive, but to make them a productive member of society is highly advantageous. So, the economics are pretty compelling.
Short lifespan single-use plastic glazing is not a sustainable solution for daylighting. Solera is the glass-based alternative for the new millennium. Learn more at advancedglazings.com. Yeah, the economics are good. And I love the aspect of it also impacts future employers. It has an impact on the mindset and the attitude of future employers, which is so incredibly powerful. Yeah. Bryan, you're doing really good things. Like I say, it's an honor having you here today. Before we go, there's two things that we have to do first and foremost. We have to ask the $1 million question. And I know it's a little bit off your sort of core business and skill set, but I'm really interested in hearing how you answer this. I ask this of every guest, and I ask them to answer from whatever perspective they'd like.
Oh.
What makes a great building?
What makes a great building? Interesting question. The problem with asking me questions like that, it's like, what's your favorite movie? Well, it always depends, right? Yeah. And it really depends upon the application of the building, right? Because what makes a great church is very different from what makes a great office building or school. But I think overall, if you're going to put up structures, those structures, they ought to be done sustainably now because the tools are there to do it. And there ought to be, eye appeal, and it ought to meld into the surrounding environment. If you're going to do something that's really a poke in the eye, it doesn't mean I don't like gaudy buildings, or Frank Gehry's approach to things, but because those are also interesting because they're meant to have you think about them and the uses in different ways. And they're meant to be eye-catching. But I think the simpler and more utilitarian of the approach can also be appealing.
That was a great answer. So before we go, Bryan, is there anything that you'd like to announce? Do you have any great news or anything that you'd like to promote?
Well, I think the only thing is if you've got listeners out there that are in the, paver business or interested in this market, I'd be happy to chat with them because we really are very interested in creating some joint ventures and potentially new businesses that would create these products. Because I think it's going to be easier to do something with some of these newer folks than it is with some of the more established folks. Doesn't mean that they're bad people. It just means there's a lot of entropy there that's keeping them going in the same direction. And to make changes is not always easy.
Yeah, that I completely relate to. So how do they get a hold of you if they want to learn more or explore some sort of partnership?
Sure. So easiest thing to do is to email me. And my email is Bryan, Bryan, at Glanris.com. And that's GLANRIS.com.
Brilliant. Bryan, thank you so much. It was a real pleasure speaking with you. I appreciate the education and I love the work you're doing. And it's very hopeful work. Thank you so much for being on the show.
Well, thanks for having me.
Absolutely. Take care.
All right. Bye.
We hope you enjoyed this episode of Better Buildings for Humans. For more information on the world's best light diffusing and highly insulating glass glazing, please visit advancedglazings.com.